Hello and welcome. Thank you everyone for joining us today. I have with me again another very special guest, Martin Eigner, who to some is the godfather of PLM. I know he's definitely been a constant in my career, but Martin, not everybody necessarily knows you that would be joining us today. Would you mind taking just a moment to tell us a little bit about yourself and maybe a little bit about your background?
Yes, Jennifer, I can do. I studied. I did a very special career. I'm tool maker. So I left school. I wouldn't like to study. I become tool maker. And then I decided to study mechanical engineering and economy. I made a PhD in applied informatics. And then I worked 5 years for the German company Bosch. And what I did there was very strong related to these things I do right now. It was a technical organization. It was a technical IT center, and it was electronic pre-development. And after 5 years, it was the time when we started with computer-aided design. It was a crazy period. It was a mixture between hundreds of thousands of manual paper drawings and then improving with CAD drawings. And this culture of mixed drawings was crazy. So we have to plot a CAD drawing and have to sign it manual. And then it was stored in the manual document archive. And so with 2 employees, we have had the idea we can optimize it. And so we founded 1985 the first PLM company in Germany. And we sold it in 2 steps. We merged with Agile 2001, and we sold the company together to Oracle 2007. And in parallel, I started a new company, a consulting company, 2003. And once again, in parallel, 2004, I became the chair of the Institute of Virtual Product Engineering on the University of Kaiserslautern. So that's my job.
That's a very amazing background. I mean, coming all the way from tool design to now having taught on product lifecycle management at universities, like you just mentioned, as well as having published a vast number of books. I think you've got at least 8 that I could find out there on the marketplace, and maybe another one.
It's more, 14.
Oh wow.
The 15th is still in process.
Okay.
Because of Corona, I have a lot of time, so I can do it.
And is the
it's 15th... a Corona book.
We'll just subtitle the Corona book of PLM.
It was written in, that was interesting, in the financial crisis, 2008, 2009. We have an interrupt in the PLM strategy, and I think we will have an interrupt based on the downsize of the economy. We will have an interrupt in the digitalization strategy too. But on the other side, I think I see some companies, they especially would like to invest in digitalization. They would like to focus on very, very precise and economically sensible things. But most of the companies have not the money to invest in the next 1 to 2 years.
Yeah, and that makes a lot of sense too, because at the same time as they're seeing an increased need for being able to do remote work and be digital,
yes.
The income is maybe a little bit different right now.
Yeah, that's interesting. We have 2 buzzwords. One is globalization.
Yes.
It goes down. And the other is digitalization and digitization. And that ramps up because everybody is working based on digitalization, video conference, streaming. Yeah, we do a lot of things. But we talk with our grandmother in the home for elder people. So they even grandmother is using WhatsApp with the video stream. So digitalization becomes public. That is one advantage. I think it's the only advantage.
Yeah, absolutely. And now this next book that you're writing, is it going to be on PLM or a more advanced topic, a next generation?
It's based on the idea, next generation, and we call it System Lifecycle Management. The reason is, I think when the story is, the history is strange. We started with PDM, or even before with engineering database, and PDM comes product data management. I think PDM was focused on engineering, on design. It was more or less the administration of CAD documents, mostly mechanical CAD documents. to store the bill of material, to send the bill of material to the MRP ERP system, and to make a partition of the entering change management process.
Mm-hmm.
And then overnight, it was interesting, overnight, the American PLM supplier changed their name in PLM, from PLM to PLM. It was maybe inside 1 week. Everybody has to follow. Nothing happened. The company was the same, the system was the same, but the promise was, yes, we save the product life cycle and we are strong. And I think it has not. It was a promise. It was a vision. I like the vision, but the vision was not executed. So I think the focus has increased against PDM. But what we have seen the last 10 years, so IoT, iOS, all the discussion about digitalization, service-oriented business models, digital thread, the international standards of sustainability and traceability. So many things came in, and we need a totally different approach of the old PLM focus. And that was the reason we called it System Lifecycle Management. We extend the focus to the very early phase, the requirement management, the system architecture, and we extend the focus to the end, to the service and maintenance and repair operation, for example, based on the digital twin. So that because we mostly administrate not only products, but systems,
yes,
mechatronical or cyber physical or cybertronical system, we call it System Lifecycle Management. But the background behind it is, it's called System Lifecycle Management, and then was a subtitle, and that was the digitalization of the engineering.
That makes a lot of sense to me. So it's really the next evolution of what we've seen over the past 40 years, from PDM to PLM, and now to System Lifecycle Management.
Can we avoid the term revolution, because in Germany no revolution was successful since many years. So we call it an evolution. So the Germans are very careful with revolution. A revolution, everybody is afraid he has to learn something different, new. His work has no value. So I call it's an evolution. So to be more carefully.
Absolutely.
And to get the acceptance.
So if we take a step back and look at kind of the history that you've witnessed and been part of and helped shape and mold, what would you say are the typical steps from PDM to PLM before we even start to get to SLM?
Yeah, I think I'm an engineer, and typically I try to speak graphically. And when you think about a coordinate system with 3 axes, then you can position exactly what a PDM and PLM system and System Lifecycle Management should be. I think the one axis is the product lifecycle. It starts with the market analysis, the requirement management, requirement engineering. Then we have a phase, I think, for mechatronical and cybertronical products. It's very important. The system modeling, that's the system architecture combined with the requirements. Then we start with a typical engineering design, mechanical design, electrical, electronic design, software design. Then we have different phases of simulation. We have simulation in early phases, for example, MATLAB Simulink. We have simulation later phases, for example, noise, vibration, harshness, or finite element analysis. Then we have a critical phase. Normally there's a gap between engineering work and manufacturing work. So we have the barrier between the engineering bill of material and the manufacturing bill of material. And then we went over to the manufacturing planning process. So what we call process planning. Process execution is typically solved by an MRP ERP system. And then at the end, we have the operational phase. That is typically the operation in the sense of business-oriented, in service-oriented business models. That's, for example, update on air, predictive maintenance, and all this stuff. So the one axis is the product life cycle. The other axis, going vertical, is are the so-called domains or disciplines. We have mechanic, we have electronic, we have software, and I added a fourth discipline, that is service design.
Absolutely.
When we design a service-oriented business model, we have to integrate the service function just from the beginning of even from the system architecture.
Mm-hmm.
So the second axis are the disciplines, and the third axis is the value chain. I think we have different operational units in one company. We have supplier, we have service provider, we have first tier, second tier, and whatever. So product lifecycle, disciplines or domains, and value chain. And then you can position a PLM system. The old traditional PLM system in the 80s and the 90s is typically positioned in one phase, the design, bill of material, CAD documents, and typically in the discipline orientation of mechanic. Maybe a little bit electric, maybe some electronic. But at that time, nobody takes care about software.
Right.
When we are flying an Airbus or an Boeing, so we have to know that the software is stored in Excel or somewhere, not in the central PLM system. And that makes me nervous.
Yeah.
And typically we have a very, very rough transfer from a supplier to the OEM. So I think we are not successful in integrating the product lifecycle, the disciplines, and the value chain. The promise of PLM was, yes, we extend. PLM means product lifecycle. So the promise and the vision was, yes, we can support the full product lifecycle, but it was not done. So system architecture was not included. The service operation was not included. The change management was typically restricted to the engineering change management, not to in coordination with the MRP system, enterprise-wide change management. We typically support mechanic, more electronic, but even at that time, software was not included. And so the last evolutionary step should be a full commitment to the three axes, the full support of the life cycle, not only as a promise, but we should execute it. The full execution is the full support of the disciplines. And that is really hard to do because the culture inside the disciplines is totally different. Bring together one mechanical engineer, an electronical engineer, and a software engineer. That's a real hard job. Yeah, that's a real hard job to make them speaking together. Yeah? Yeah. And then on the other, to integrate the supply chain. So that's it's a great job to do that. And we have not done it right now. We are just starting. So System System Lifecycle Management, I feel it's just on the beginning, but we have to push it forward.
Absolutely. And so really with PDM being the first step of getting your computer designed objects under a change control process, then moving a little bit further into actually including other parts of the organization with that lifecycle management. And now the next evolution, of course, taking it even wider. During that, you mentioned a lot of things that have failed in PLM implementations. And I know we're both proponents of enabling obviously businesses and people and processes with technology, but, all of the missing components aside that are going to be in the next evolution of PLM, why do you think so many companies have struggled to even succeed with the current definition?
Yes, the definition is nice, but only with the definition we will not save the world. That's for sure. Yeah. So, and I think we will have the same technical, organizational, and cultural problems. So I think PLM, in the old understanding, it was on the department level a technical solution. And that was one reason we failed. When you compare PDM or PLM against, in Germany, SAP or worldwide MRP, if MRP asks for a new version, it costs about 2 million euro. It's not a problem. Right. If you ask for 2 million for an engineering tool like CAD or PLM, it's a disaster. So the PLM philosophy is not accepted by the C-level of the management. So PLM and PDM was done on the department level. That is one main problem, and that is something we have to change. And based on this strategy of digitalization, we have a challenge to change it. PLM could be a part of digitalization of the engineering process, but it's not done. We have to fight hard to convince the management that it's management level and not the department level. I think on the other side, the PLM system, I think as an engineer, no engineer will ever be satisfied with a technical solution. That's the reason of any. That's the base problem of engineering, and that's why we do, why we invent new things. And I think when you ask 100 companies what's about their PLM implementation, I'm quite sure 70% or 60% will say, we did not get this what was promised from the supplier. Maybe 20% went, okay, it's reasonably good and we can work, and maybe only 10 to 15 or 20% say, oh, it's a great thing. I think engineers are more critical against technical solution. I think I never heard somebody about SAP crying it's a bad system. So they are trained to work a whole the day with MRP system. An engineer may work maybe 20 to 60 minutes a day. So he is not trained. It's not a permanent working system. Right. It's a temporary system. And so the systems has maybe a bad user interface, very complicated. And I think the main topic is that the system supplier promised out of the box. And that for me, it was the most stupid announcement of the world. And an MRP system is easier to adapt because the processes are more stable. In engineering, you can compare engineering always with ETO, engineering to order. It's always an order-oriented project depending work. So right. It's a very critical and time-consuming, and we have a lot of impact from outside. We have feedback. We have steps back, step forward, and that is the problem that we have never forever. We have a PLM solution or PLM solution out of the box. So the supplier promised a solution out of the box. It's just jumping out of the box. You can implement it, and the next day you will be successful. And that was a bad experience of all the engineers who have to implement the solution.
So I heard a lot of different things there with the challenges in product lifecycle management, from the perception of what it could do and would do and how long it would take to get there.
Yes,
and
exactly.
Then management perception too on what value it would bring to the company, and maybe not as much involvement as you would like to see. What would you say to any executives or VPs of engineering and whatnot that are listening with us today? How can they improve their adoption? Is there a particular infrastructure that they need, or just a commitment? Like, what's going to help them drive that value forward?
Yeah, the first thing is there's a cultural difference between the United States and Europe. It's like if you order a car in Germany, you have 10 powered by 28 options.
Yes.
Each car is designed special for you. In the United States, you went with your family to the car trader and think, oh, this red car with the special rims, I like it, and he took it. Yeah, that's totally different. In the United States, the cars are produced and then somebody will buy. In Germany, each car is special designed, 10 powered by 28 options. That is unbelievable. And the same culture is when the Europeans are investing in a technical IT solution. They try to do the same. I think the European type of customizing is on a very high level. So we should restrict ourselves. That is the first method. I think we talk about bad customizing, but first we have to reduce the customizing. We have to come closer to the standard. I never accept out of the box, but what the Europeans are doing somewhere, we have seen very often they customize so many things that after 1 or 2 years, they have to recustomize it back to the standard. So we have to be careful. That's that's an educational principle. Then the next step is we need system. I think in today's technology of software, it is so stupid that when we did the first customizing, then we get a new version, for example, PLM 2.0, the next version, and then we have to invest 20 to 30% in doing the work once again to use the old customizing from the old version to transfer to the new version. Stupid. We have companies. We have a big automotive company in Germany. They are doing crazy things. They are far away from the actual version. They get the original version, they do customizing, let's say about 2 years. After 1 year, they got the new version of PLM, but they have not finished to customize the old version. Yeah? So at the end, they are 1 or 2 versions behind the actual version because they are not able to keep track of the lot of work of customization. And then in general, I think, reduce yourself in customization. Buy a system which is doing the customizing when you get a new version automatically, like ours. I think I do not understand why people are not following this decision or this proposal. When I see a benchmark, the engineers are testing 90% technical features and function. They are testing even features and function. They never test how easy it is to transfer a version 1 from the PLM system to a version 2. I have never seen a benchmark who is trying to find this out. Man. I think that is my main recommendation. And then I think we have to accept that engineering is a more creative process. Creative people don't like. They feel a little bit controlled by a PLM system. Yeah? And so we have to build a user interface which is more like an iPhone or something, and not so you see a lot of rows and tables and whatever.
Yes.
I think we do not support, and other things are missing. How are we able to convince management when the management is seeing stupid rows and columns and bill of materials? I think we have to show management statistics, reports. We have to help the management to get information. They can do better decisions and execution.
And that's the key.
That's the real
absolutely
key.
The key.
The MRP system, out of the MRP system, a manager get a lot of information for daily decisions. From PLM, he will get nothing. Yeah? And so we have to guarantee the acceptance. We have to reduce the total cost of ownership. We have to reduce the customizing at all. We have to fight for a better acceptance on management level and on application engineers level.
Okay.
Yeah, I think only with switching from PLM to system, we have not solved these problems.
No, we definitely have not solved the problem just by changing the acronym.
Exactly.
So what would you say is really still missing from your viewpoint for the future of PLM?
Yeah, I think the topic number 1 is the systems. The most of the PLM systems are born in a mechanical CAD environment. If you look on the competition of ours, Dassault, PTC, Siemens, they are all coming from mechanical CAD. There are only a few systems coming from electronic or are still independent from any CAD impact. And so I think the interdisciplinarity is not guaranteed. Most of the PLM systems, they try hard, but it is not really done. Interdisciplinarity means to understand the culture and the different engineering processes for mechanical, electronic, and software, and especially software. When you talk with engineers, mechanical or electronic and electrical, they talk about bill of material. The drawing or the 3D model and the bill of material is their communication base. And then these crazy software guys are coming in, bill of material, never seen. We have trunks and merges and baselines, and they have a totally different engineering change management.
Right.
And so you have to understand the different culture, the different engineering processes, and you have to embed these different engineering processes in your system lifecycle management system. Yeah? You have to build the engineering processes first. In most of the companies, there is not an integrated interdisciplinary change management in place. That's something that has nothing to do with the SLM system or PLM system. That must be done by the management. Right. And then we have to deliver a system which is able to do a software change, an electronic change, mechanical change. And at the end, we have to integrate all the disciplines in one traceable bill of material. And that is not done right now. And that is part of the concept of the system lifecycle management, because the interdisciplinarity is the absolutely necessary for the traceability. You are not able to trace a product with the software in Excel or the electronic in another PLM system and mechanical stuff in another. So we have to do a real mechatronical integration of all the three disciplines, and then we can talk about traceability.
So with that, you actually mentioned something that I'm hearing a lot from people that I'm talking to out at manufacturing companies, where they're discussing the idea of harmonizing their global engineering processes across the different disciplines.
Yes.
Is that a task that can be supported by PLM while they're trying to figure out how that should look and how those different teams can coordinate, collaborate together? Or is it really something that they should do in advance of trying to enable it on the system?
I think it's, Jennifer, it's like car driving. You can buy a car, but that does not mean you can drive the car. You can buy it. So I think driving is something you have to learn, and the car should support you to drive. I think when you talk about engineering process must be provided typically before you made a decision. You can do it mostly in parallel, but engineering processes are coming first. And then a modern system lifecycle management solution should support these processes. It should be as flexible as possible, because we have total different manufacturers. We have mass series production, we have engineering to order, we have assembly to order, we have single unit production so maybe we have a company near of my home, Eigner, they do the drilling machines for tunnel that are huge machines, always very special. And they have all different processes and focusing. And therefore, the engineering process must be defined before. The PLM or SysLM system should support different types of processes. And the PLM supplier should have experience to be a positive consultant to join the party. I think the PLM supplier is not responsible for the engineering processes, but you have to combine the possibilities, the potential of the system and the processes. Sometimes I have seen they generate so complicated processes that no system on the other side is able to solve, to support this process. So it must be done hand in hand. But it is a real prerequisite for a good PLM implementation. And once again, that's not solved with system lifecycle management. Even it becomes more complicated, because with system lifecycle management, we try to cover, once again, the full product lifecycle, all disciplines, and the value chains. That does mean the process is becoming more complex.
Absolutely. And then, of course, most companies no longer really stay static in their processes either. So once they've gone through the iteration of defining this global process and done the harmonization, they've enabled it on the technology to support their business users. 3, 5, 7 years from now, they're going to need to make changes and update again.
Yes. Yeah. That is what we called, on the one side, agility, because we have not only support agile processes. I think whole the company is agile. I've seen many companies who merged with another. They have bought a company in China, in wherever in India. And then we have to, that the real problem comes, we have different cultures, we have different processes. We have sometimes we have different part numbers, simple stuff, part numbers, item numbers are different. And then we try to harmonize on this level, and it's a real hard job. So it's agility and what the American call resilient. The solution should be resilient. You must be able to integrate other companies, other cultures, other countries, other global areas, and that is a permanent job and challenge to do.
All right. Well, thank you so much, Martin. Is there anything else that you'd like to share today?
No, I think we talked about most of the things. I think we have to keep in mind the person with driving is, once again, the PLM system is a car. We have to learn to accept the car, and I think we have to do many things more in the human resource area. We have to do many things on management and the organizational stuff. I think with digitalization, more and more companies have a chief data officer or chief digitalization officer. I think I foresee changes in human resource, in organization, and in technique. And we have to bring this stuff together for a good, successful SysLM implementation.
Absolutely, I agree with you. The people are the most important thing. They're the ones that are ultimately going to enable the process, and the technology should absolutely be there to support them.
Yeah. Okay.
All right. Thank you so much, Martin. I look forward to having you back again in the future whenever we'll talk about the digitalization of engineering.
Okay, we do. Okay. Have a nice day.
You too.
Bye-bye. Bye-bye.
Thanks, everyone, for joining us. We really appreciate the opportunity to share lots of insight and information with you about running technology projects and making them more successful in your organization, no matter what type of technology project you're doing. Liked this content? Make sure to hit that button and subscribe. And of course, drop your comments or send me an email at jmo@minerva-plm.com about any questions that you have that you'd like to see addressed here. Thanks, everyone, and have a great day.